8.8 is exponential growth and decay. Yesterday we learned about exponential functions. We're going to apply this to applications where we're going to be modeling the exponential growth and decay. So remember, the exponential function comes in the form of y equals a times b to the x, where a is our initial amount, and remember y was our total final amount, and b stood for growth factor or decay factor. So this tells you how something grows or decays. And remember, x was the number of times it decays or grows or decays. So we're going to keep using this equation in this section today. So the new thing about this section is that we're going to be dealing with interest rate, so how it affects our b values. For anything with the interest rate or anything with a percent, what we do is we're going to take the 100% and we're going to add the interest rate to it. For the decay factor, our b value will be 100% minus the interest rate, or whatever the rate of percent is. And we will also be talking about half-life of a chemical compound. So in our first example, in 1998, population of 13,000 people has increased about 1.4% a year since. So what we're going to do is we're going to write an equation of an exponential function for this situation, and we're going to solve to see how much population will be in 2006. So we're going to start with our initial amount, which is our A, and we get that from right here. It started at 13,000 people. Now remember, for a growth factor, because it's increasing at 1.4% a year, our B value will be 100% plus 1.4%. And when we add it together, we get 101.4%. And we always convert it to decimal when we're doing calculations, so we move it over 2, so this becomes 1.014. So that is our b value. So when we write our equation, we get y equals 13,000 times 1.014 to the x power. So now once we have our equation, we can figure out how much population will be in 2006. Well, I want to know how much population is in 2006. So it was increased once a year at 1.4% since 1998. So I want to know how many times it increased. So we're going to take 2006, take away 1998, and it has increased 8 times. So x would equal 8, so we plug it in, x equals 8. So y equals 13,000 and 1.1014 to the 8th power is 1.117644, and when we multiply that together, the population is about, we're going to approximate 14,529 people in 2006. So this is one of the examples out of 5 that I will be talking about today. In example number 2, we're going to be talking about investments. So before we move on to investments, the interest rate that's given can be compounded differently. So if it's annually, it compounds once a year. So we're just going to keep that same interest rate and we're going to use that. Semi-annually, it compounds twice a year, 2 times a year. So what we do is we take that interest rate and we divide it by 2. In monthly, it's 12 times a year. So we take that interest rate and we divide it by 12. Quarterly means it compounds 4 times a year. We take that interest rate and we divide it by 4. And we don't go as far as daily, but daily means 365 times a year. So you take that interest rate and we divide by 365. So in this situation, in example number 2, we're going to deposit $1,000 in a college fund with an annual interest rate of 7.2%, and it is compounded annually. So what we want is we want to find the account balance after 5 years. So we're going to write the equation first. So we're going to find our initial value, which is A, and we start with $1,000. And B, because it's increasing and it's compounding at 7.2%, we take 100%. We add 7.2%, which is 107.2%. And we convert it to decimals by moving it over 1 1.072. B is our B value. So our equation now will be y equals 1,000 times 1.072 to the x power. Now it's compounded annually. That means once a year for 5 years. So our x has to equal 5. So 1.072 to the 5th power, we type that in your calculator, and this becomes y equals 1,000 times 1.428, 1.14157, and that will give us $1,415.71, and that's compounded annually for 5 years without putting additional money in. That's how much you'll end up with after that. Now what we're going to do is we're going to take the same situation and we're going to compound it quarterly this time. So A is the same, $1,000. B, we have to find the new interest rate. So remember, compounded quarterly means we take the 7.2% and we divide it by 4. So we're compounded quarterly. So that becomes 1.8%. So now my B will be 100% plus 1.8%, which is 101.8%, which is 1.018 in decimals. So now our equation becomes y equals 1,000 times 1.018 to the x value. Now, it's compounded quarterly for 5 years, so that's going to happen 4 times a year. So x will be 4 times, this means for the quarterly, 4 times a year, for 5 years. This is 5 years, so it's going to compound 20 times. So our x will be 20. So when we take that to the 20th power, it's 1,000 times 1.4287. 1.018 to the 20th power is 1.47, which gives us $1,428.75. So I'm going to, there's more decimals there, so we're going to round up. So if you notice, more often it's compounded, more money you will make. In example number 4, we're going to talk about half-life. So chemists use this when they're dealing with chemical compounds. So what it means by half-life is that every 6 hours, the amount of chemical that we have cuts in half. So that's what we call a half-life. So 6 hours, after 6 hours, it's going to cut in half. So if there's 80 milligrams of this compound, I want to know how much is there after 24 hours. So we're going to start the same thing again. Our initial amount is 80 milligrams. And because this is half-life, B will always be half. That's how it cuts in half. How does it decay? By half. So B is half. Okay. So my equation will be y equals 80 times 1/2 to the x power. Now the next question is, how many half-lives after 24 hours? So half-life is every 6 hours. So there are, so number of half-life is given by 24 hours divided by 6 hours, which gives me 4 half-lives. So there are 4 half-lives, and that's what will be our x. So when we plug into our equation, y equals 80 times 1/2 to the 4th power, we will have 5 milligrams left after 24 hours. So just think of it this way. We start with 80 milligrams. After the first 6 hours, it cuts in half. So this will go down to 40. After another half hour, 6 hours, it cuts into 20 because it cuts in half. Another one after another 6 hours will be 10. And then one more half-life, one other 6 hours, we have 5 milligrams. So you could do it this way, but I would like to see this when you set up your equation. Our last example has to do with decrease. So this is a decay with percentage. So the population of endangered species decreases 2.4% each year. In 1999, there were 60 species. So we're going to write the equation again. Our initial amount is 60 species. This is a decay, so my B would be now, instead of 100% plus, this will be 100% minus 2.4%. Which gives me 97.6%, and that in decimal becomes 0.976. So our equation now would be y equals 60 times 0.976 to the x power. And it's decreasing 2.4% each year. So to figure out how many times it decreased from 1999 to 2005, our x will be 2005 minus 1999, which happens 6 times. So we're going to plug in 6 for that problem. So 0.0976 to the 6th power is y equals, this gives me 0.864368. Taking this to the 6th power, which gives me approximately 51 species in 2005. And this is all the examples with growth, exponential growth, and exponential decay. And all 5 types of examples will be on the test. So just remember, when it's decreasing, you subtract to find your B value, and when we're increasing, right here, increasing in percentage, is you add to find your B value.